Welcome back, everybody. Today we're going to continue our look at Java arrays with 6.3 by talking about arrays of objects. Now, technically we're not going through anything new, anything you haven't already learned about in this lesson. Okay, we've actually already dealt with arrays of objects when we've done arrays with strings in them. Okay, the big thing we're going to do today is remind you how objects work and mainly are stored in Java, and then talk about the implications that has as we go to put those objects into arrays. Okay, so a big part of today is just going to be a review of how objects work, which is good, and we'll talk about what that means for when we make an array of objects. So first thing we're going to review or remind you about is the idea of a reference variable in Java. We'll just say references. Okay, in Java, any variable that refers to an object is a reference variable. Okay, and we'd say the reference variable stores the memory address of the actual object. Okay, so again, in Java, when we create variables to store objects, they don't actually physically hold all the information of that object themselves. They store the address, okay, of where I can find that object and all its information off somewhere else in the memory. Now next, let's just give you a simple class to use as examples as we go through the rest of the lesson here. So let's say we have the monster class for making monster objects. And the only thing we want to know about a monster is its height and weight, so that'll be what we store. Okay, our constructor looks like it just sets that height and weight. Now we have a grow method here quick, which adds 1 to the height and 100 to the weight. And then I also have, it looks like the equals method technically overridden, and then the toString method overridden. And reminder, when I override these methods, I can make them do whatever I want. We'll say in this case, the equals method returns true if the monster we call it on and the parameter monster have the same height and weight. And then the toString method just returns height, comma, weight of that monster. Okay, so basically about as simple as a class as we can make. Again, we're just using this for an example as we go through the rest of the lesson. So next, let's just remind you real quick of what happens when we actually create a monster object. Okay, when I run the code monster m equals new monster 7300. Okay, well what that does is it tells Java to create space in memory for a monster reference called m, which will be stored here. And when it sets it equal to a new monster 7300, what that's going to do is it's going to create a monster object with height set to 7, with weight set to 300, with some different methods we can run. And then at that reference variable m, it's going to store the memory location of where I can find that object off in Java's heap. Okay, so we'd say m is a reference variable that refers to a monster object. And then we'll just remind you about how kind of setting objects equal to each other's work. So again, let's say I have a monster called x with a height of 700, weight of 300, and then I say monster y gets x. Okay, what's happening here is we're not creating two different monster objects. We'd say that x and y store the same memory address. Okay, so in this case we have two reference variables of monster objects, x and y, and they're both storing the same address. They're both pointing to the same object in Java's memory heap. So if I set two objects equal to that like that, okay, just a reminder, if I want to print is x equal to y, that would be true. And that equals talking about is do they store the same information, in this case the same memory address? And then also does x dot equals y, okay, that's going to be referring to our overridden equals method that returns true if both the height and weight are the same. Well, in that case that'd be true as well. Now let's contrast that with this set of code where I make two monster references and call the new monster constructor on both of them. Okay, in this case we'd say that x and y store different addresses. Okay, where x is pointing to one monster object, y is pointing to a different monster object. They store the same information, but those are two different objects in the Java memory heap. So now when I run this kind of second chunk of code here, does x equal y, that's going to be false, okay, because those two references store a different address, okay, and that's what this equals checks is exactly what they store, and those are the addresses. But in this case, my x dot equals y would still be true, because remember when we had that method, it compared the height and the weight, which would be the same for the two of these. All right, so after that quick review of how objects work and are stored in Java, let's talk about what that looks like in terms of arrays. We'll say array of references. And here what we're talking about are arrays of objects essentially. But what that array is going to store isn't the actual object itself, it'll be the references to that object. Okay, so let's go through some code. When I want to create an array of objects, what I'll do is I'll just say what type of object I want with the square braces here. Just like if I want an array of ints, I'd say int braces, or if strings, which are objects, I suppose, we'd say string braces. Okay, we'll give that array of objects a reference name. In this case, we'll say list. And then we'll call the new constructor the type of object, and then plug in a number to size that array. If I run this code, essentially in the memory, this is what I'm going to end up with. Okay, an empty array, we'd say, with 8 spaces in it, okay, for this size of 8. And then just like if I made an empty array of ints, it would give it all the 0 value of zeros. Or an empty array of booleans, it would start off with a boolean 0 value of false. Anytime I make an array of objects, okay, using the new constructor, it is going to set them all equal to basically the 0 value for an object, which is null. In other words, it's a reference variable that doesn't point to anything. It doesn't have an object there yet. Okay, so if I run some more code then, let's say I say list at index 2 equals a new monster with size 7 feet high and 300 for a weight. What that's going to do is it's going to remove the null pointer in space 2, and it's going to fill it with a reference variable 2 with it holding an address to that actual object, okay, so a pointer to that object. If I go to print things then, if I printed out what was in my list at 0, I'd get null. Okay, in other words, we'd say that this reference doesn't point to anything yet. If I did 1, I'd get null as well. But then if I got to printing out at index 2, we'd get the 2 string for the object that that points to. Okay, so again, big thing here is when we create that array, that first line of code, we're going to have an empty array. In other words, an array filled with null pointers. And then actually use the stuff in that array, we have to fill it up, and then we can actually deal with it and make things happen. Now, just a reminder of one way we can deal with arrays that aren't all the way full yet is by using this code. So let's say I create that same monster list, okay, with 8 spaces in it. And let's say I fill some of those spaces with some different monsters. And let's say I want to write some code that goes through every monster in that space. In this case, we'll just print them, but we could do something where we compare them, where we search for a monster, where we add all the monsters' weights up, a bunch of different stuff. One thing I can do to avoid those null pointers and not print them out or add them in calculations is as I loop through that array, I'll kind of wrap whatever I want to do within this extra conditional, where we'll say if the list that I is not equal to null, then we'll do whatever we want to do. Again, in this case, we'll print it. Okay, this is kind of a simple way to print all the monsters that are in that array and ignore all the null spaces. Okay, as far as printing goes, we can handle the null. It'll just print the null out for us. Maybe that's not what we want. But if I want to do some calculations with something that's null, that would actually break my program. That would give me a null pointer exception. Okay, so this chunk of code right here, this extra conditional within our loops, is going to be something we use very commonly, okay, when we're dealing with arrays of objects. Next thing we're going to talk about is how to actually access the objects stored within an array of objects. So what I mean by that is, let's say we create an array of monster objects. We'll call that list once again. And let's say we put a actual monster object, we instantiate an object at index 0 in that list. So the question is, how can I access the object in that spot on the list? Okay, how can I call methods on it? How can I get the information? Well, the way we're going to do that is with our dot notation, which is nothing new. Okay, it's something we've used a lot on our string objects, okay, such as dot substring, dot length. Okay, the dot notation grants access to the object at the stored address. Okay, so if I want to get access to the monster stored at list and space 0, we'd say list 0, referring to the monster there, dot, and then I can call my different methods such as grow. Okay, I could use my getters, my setters, all that different stuff. Okay, so just like I had an object here with a reference variable, we can use the list at the index dot method to refer to it. All right, and last thing we're going to talk about quick is how to and what happens when you make changes to the references or to the object stored in an array. Okay, this is something that makes practical sense. Maybe I'm holding onto a list of some type of objects and I want to switch the objects in that list. Okay, so let's say, for example, we have an array of, we'll say, monsters again. And it looks like the first 3 spaces are filled. In other words, they store a reference to a monster object. Okay, their addresses point to actual objects off in the heap. And let's say I run this code, list at index 2 gets list at index 1. Now this is going to be similar to what we did with just our objects, where we'd say x gets y. What's going to happen here is we're going to remove the address stored at index 2, which essentially removes the pointer to this third monster object. And then we're going to set it equal to what's stored at index 1, which is this address here. So that's now going to be at index 2. So in other words, our list at index 2 points to the same monster object at index 1. And anytime in Java that an object doesn't have anything pointing to it, it will garbage collect, it will clear out that object, erase it from memory. Okay, so this would be the result of running this line of code here. Okay, 2 different monster references, 2 spaces in that list that point to the same monster object. Okay, just one more example quick. Let's say I start off with the same array of monster objects. Okay, the first 3 spaces are filled, all pointing to different monster objects. And then let's say I run this line of code, list at index 2 gets null. Okay, this would be the code I'd use if I want to remove an object from my list and not replace it with anything. What's going to happen here is, once again, my address is going to be cleared out in index 2, which clears out the pointer to that object. It's going to fill it with the value of null. In other words, our array at index 2 is ready to store a reference to a monster object, but there's nothing there yet. Once again, since we had an object with nothing pointing to it, Java would garbage collect and get rid of that object there. Okay, so this would be how I would clear out a list, remove items from it, without actually replacing them. Alright, so there you go. That's how arrays of objects work in Java. Again, technically nothing new there. We've already talked about how objects work. We've already talked about how arrays work. Okay, the difference here is we're talking about kind of explicitly how the two of them interact here. Okay, so hopefully you think that was a good review of some of the object stuff we've done as well, and then also a review of how arrays work as well. Okay, so done with the lesson. Start working on some programs, start cranking out some code. Let us know if you need any help, and we'll see you folks later.